Let's go to the FRQ question number 1. There are 4 parts in this question. First one, to define luminous flux, luminous illuminance, their units, and also luminous intensity. Second, to apply the equation to solve problems. And third and fourth, to relate them. That means to solve problems with equations. Okay, so you have to know the definition of these 3 terms: luminous flux, illuminance, and luminous intensity. So luminous flux, the letter is P. Most likely you are going to get a match the following for this question. So you have to know the definition, symbol, unit, and equations. Okay, so luminous flux, the letter is P. It means the rate at which a source produces light energy. So if you have a bulb, it will produce some light energy, right? So the amount of light energy produced by that bulb, the rate, that's called luminous flux. It will be constant for a bulb. Wherever you stand, if you stand near or if you stand away from the bulb, it will be same for one bulb. The distance does not matter. And the unit is lumen and its letter is Lm. Okay, hope you got that. Second, illuminance. Illuminance means the light falling on a surface area. So that depends on the distance. When you go away from the bulb, the illuminance decreases. When you come near to the bulb, the illuminance increases. The illuminance is denoted by the letter E, and it is the luminous flux falling per unit area. So illuminance also have the equation E is equal to P by area. So that is equal to the flux by area. Okay, now the unit is lux. So since it has the unit P by A, you can also write the unit lumen per meter square. Okay, because lumen means P and meter square means area. Now luminous intensity, that's letter is I, and it is the luminous flux that falls on 1 meter square of the inside of a 1 meter radius square. So it is the flux again, which fall on area of a unit sphere. So that is the definition. If you see the word a sphere, that is luminous intensity. Okay, inside a sphere, if there is a unit area, the light falling on that particular area, that's called luminous intensity. And it depends on the angle at which light falls on it. And the unit is candela and the letter is CD. Hope the definitions are clear to you. We have 3 more equations. Only the first equation will be in your equation sheet. So the second and the third, you have to memorize it. It's not going to be in the equation sheet. Okay, so the first one is the equation between E and P, illuminance and flux. Okay, this two, connecting this is P by 4 pi r square, which will be in your equation sheet. But the second one, connecting illuminance and luminous intensity, that will not be there in the equation sheet. Memorize it. And the third one, connecting luminous intensity and the flux, that's also not in the equation sheet. So IV and P, that also you have to memorize. So memorize the 2 equations so that you can solve the problems quickly and easily. Okay, if you want, you can take a screenshot of this page. So most likely you're going to have a question like this to match the terms in the column 1 to the other columns. So if you have this as the first, second, and the third, what is the letter for luminous flux? Can you say that? It's P, right? So you can match. You can draw lines in the exam and you can match. Then illuminance, what's the letter? It is E, not I. Although the illuminance starts with I, the letter is E. Okay, so that's 2. And number 3, luminous intensity. Intensity is the letter that we use. So I, it's 3. Now the definitions, the rate at which the luminous source produces light energy, the rate at which, so it depends on the source, that is the luminous flux. So it's going to be 1. Now, luminous flux falling on an area, if you see flux per unit area, it is illuminance, right? So that's 2. If that luminous flux falls on area inside a sphere, then that is luminous intensity. So that's number 3. Okay, now you know the units. Luminous flux, what's the unit of luminous flux? It's lumen, right? So number 1 is lumen. Number 2, illuminance. What's the unit? It's lux, or another lumen per meter square. Any one of them can be given in the questions. Now, candela for luminous intensity. So match them according to what is given by drawing lines. Now you know the equation for luminous flux. Luminous flux is P, right? It's P, and illuminance is E, and the luminous intensity is I. So which of them have these equations? Can you tell me? One of them is in your equation sheet. You know that E is equal to P by 4 pi r square, right? So it is the equation of the illuminance. So this falls for second. Now, now when you rearrange this equation, E multiply, if you rearrange this equation, E multiplied by 4 pi r square, that gives the P, isn't it? So rearranging gives P. So that is the equation for the flux. So that's going to be number 1. And the formula for IV, which is not in your equation sheet, that is P by 4 pi. 4 pi means the solid angle on which light falls. So angle is related to the luminous intensity. So that's number 3. So hope you know how to match this definitions and equations and the letters units together. So this is going to be a part of your first FRQ. Hope that's clear to you. Now let's solve some questions related to the topic. Let's go to the first question. A 64 CD point source. So if you should know the units to identify the quantity, because they will not say in the question what it is. They just said it's 64 CD, which is candela, and you should know that it is a unit of luminous intensity, right? You can put I as the letter, or you can use IV as the letter. Now, it is at a distance 3 meters away. Meter is for distance, so the letter is R from the painting. The question is, what is the illumination of the painting? So you are going to find E. There's 2 ways of doing that. This is the equation in your equation sheet. So you can find P is equal to 4 pi by IV, or you can use the equation I equal to P by 4 pi, which I told you to memorize, and then find P and then find E. But the easy way is to use the equation between illumination and luminous intensity. I told you this equation is not in the equation sheet. So memorize this equation. E is equal to IV by R square. That equation you can use directly. E is equal to I by R square. Okay, I is the luminous intensity, which is in candela. So 64 by the distance is 3 meters. Make sure it is in meter. If it is in centimeter, divide by 100 and convert to meter. Okay, so now it's in meter. So just put 3 square. And when you plug it in the calculator, you will get 7.1. And the unit of illuminance is lux. Or you can write lumen per meter square. So this is the easiest way of solving. This is the advantage if you memorize this equation. Okay, so if you want, you can take a screenshot or write it somewhere. Hope that's clear to you. Let's go to the next question. This is the most important question in this chapter. You have 2 light bulbs, and they say that they illuminate the screen equally. What do you mean by illuminate the screen equally? It means that the illuminance of the first bulb is equal to the illuminance of the second bulb on the screen. So we can write that E1 equal to E2. Now we can see what is given in the question. There is one bulb, which is P, and it is written as, we can write it as P1. That is the flux of the first bulb. And the second bulb, it is P2. Let's take it as P2 because they are different. There are 2 different bulbs. So P1 and P2 will be different. So look at P2. Now, for the second bulb, the R2 is given in meter, but for the first bulb, the R1, the distance is not given, right? So the question is, what is the distance of the second lamp from the screen if the luminous flux is 2375 lumen? Okay, so we want to find the R1. Actually, in the question, they have taken this as a second bulb, so we can consider that a second bulb. So this is P2, this is P1, this is R1 and R2. Okay, so read the question first and then give the letters. So this is the second bulb, and then we have the first bulb. So we start with E1 equal to E2. Since the P and the R are given, we are going to start with the equation E is equal to P by 4 pi R square. This is the equation between E and P, right? So you have 1 mark for writing the equation and equating it. So first you have to write that the equation of E1, which is P1 by 4 pi R1 square equal to, for the second bulb, P2 by 4 pi R2 square, right? Now we can cancel the terms which are same on both sides. So P1 and P2 are different, R1 and R2 are different, we cannot cancel them, but 4 pi and 4 pi are same. So just cancel that and we get the equation P1 by R1 square equal P2 by R2 square. Okay, so this is how you have to start your answer. You have to write the equation because you are marked for writing the equation. Now you can put the values. The value of P1 is 1445 divided by R1 is 2.5 square equal P2 is 2375, the second bulb, divided by R2 square, right? Okay, so now you can plug it in the calculator directly. No need of further steps because you only have marks for the formula, substitution, and the answer with unit. If you don't write the unit, you lose half mark. And if you don't write the substitution, you lose 1 mark. So substitution and formula and the units with answer are very important. So after writing this, you can directly plug this into the calculator. In the place of R square, put X in the place of R2 and just check your answers with the calculator, because most importantly, you need to know how to use your calculator. Okay, you can cross multiply and do, or you can plug into your calculator directly. Most of you might have used your calculators for solving this. Did anyone get the answer? Have you tried this? So the answer for this question is 0.4438 meter. Sorry, just a minute. Yeah, 3.2 meter, correct. 3.2 meter. Okay, that's the R2. So this is how you solve this question. Hope it's clear to you. Now, a similar question, but using another formula. It's also very important. One of them or both of them can be asked in your exam. So this is 2 lamps again. They illuminate the screen equally. If you see this, you should know that E1 is equal to E2. Okay, so there's lamp A and lamp B. We can take the lamp A as the first lamp. E1 equal to E2, and the distances are given R1 and R2 for the 2 bulbs. Now, there is a lamp A rated 75 CD. What do you mean by CD? It is the I, right? The luminous intensity of the A is given. So I will take I1 as 75 CD. Now, what is lamp B rated? So rated, here they have mentioned the word rated 75 CD. So you should understand that they have asked the luminous intensity of the second lamp B. Okay, you want to find I2. That's our question. So we start with they illuminate equally. So E1 equal to E2. That's our first equation. Now we are going to use the equation between E and I. Okay, you know that if P is given, you have to use the equation between E and P. But if I is given, you have to use the equation between E and I, which is E is equal to I by R square. Okay, so we'll just plug in that I1 by R1 square equal to I2 by R2 square. Now plug in the values. I1 means 75 over 5 square equal to IB, which is I2, we don't know, divided by 3 square. Now, plug it in the calculator, put I2 as X and find it, or you can cross multiply and do. The answer would be I2 is equal to 27 CV. You can check with your calculator. It's very important to check every question's answer that you are getting with the calculator. Okay. So hope that's clear to you. Now, one final big question about this. Let's go to this question. Here we have to find the distance again. There is a lumen given here, the luminous flux of the candle, which is P. And the distance of the candle is given. Now we want to find the luminous flux of the lamp is given 22500. And you want to find the distance t, right? So let's take any one of them as the let's take the candle as the first one. And they say the illumination is equal. So E1 is equal to E2. Let's take as a candle as E1 and this is E2. So the P of the candle is P1 equal 1500. And the distance R1 is 0.34. P2 of the lamp is 2500 lumen. And we want to find the R2, right? So you will just use the equation E1 equal to E2. It's same as the previous question that I've solved. So I'm just going to skip the equation, skip everything. I'll tell you the answer. You can try for yourself. P1 by 4 pi R1 square equal P2 by 4 pi R2 square. So the 4 pi and 4 pi cancels, and you will just substitute the values and you will get the answer R2 as 0.438 meter, which you can round to 0.44 meter. Okay, so that is the answer. You only need to have 2 decimal points, so you can round the remaining numbers. Okay, so check whether you get this answer. Let's go to the next part. They say that the lamp is moved towards the screen so that the distance became 0.31 meter. Find the ratio of the illuminance in this case to the illuminance before the move, right? So we will use the formula again. They want to find E2 by E1. Find the ratio. Ratio means the division, right? So we will use the formula E2 over E1. Illuminance is inversely proportional to the distance square. So if you want the formula between illuminance and distances, E is directly proportional to 1 by R square. So if you want to find E2 by E1, you have to put the opposite. So E2 is inversely proportional to its distance square. So R2 square will come here. And R1, the E1 is down. So R1 square will come to the top. Okay, this is how you can find the ratio easily. Now, which is the first case? They say that the first case is the case when before the move. Before the move is the first case. Before the move, the distance of the lamp was 0.44 meter, right? The answer of the first case is the R1 in this case, because before moving the lamp was at a distance of 0.44 meter. But now it is moved to 0.31. So that is the R2. You get that? So that is what they want you to find. The ratio of luminance after you move to 0.31 to before it was at 0.44. So that is why we take R1 as 0.44 here in this question and R2 as 0.31. Okay. Please make sure that the candle has nothing to do with question B. It's only about the lamp. So we are not considering anything about the candle. We are only considering the lamp's two positions, one at 0.44 and the other 0.31. So let's plug in the values. 0.44 square divided by 0.31 square. That will give you the answer to 0.0145. So the ratio is this value. Do you know what's the meaning of this ratio of the illuminance? It means that when you moved it closer to 0.31, that means you moved it closer to the screen, right? The ratio became 2.1. That means the illuminance became double on the screen. You see the number 2? 2.01 means more than 2. It became more than double. The screen became illuminated double time, twice. That's the meaning. Okay. So that is all the questions for the first FAQ. Let's go to the second FAQ that also has 4 parts. It's about mirror. Apply the mirror equation to calculate object distance, focal length. And second one, to define magnification. Third, to calculate magnification. And fourth, to draw the ray diagram of a convex mirror and the properties. So these are going to be the 4 parts of your second FAQ. For that, I have put the equation sheet. You can take the screenshot. These 2 equations are going to be in your equation, but the remaining you can memorize or you can solve it just in the equations given. You can plug in the calculator and do directly. Okay, but if you want to use the memorized equations easily, you can study the 3 equations of F, XO, and XI. So F is the focal length, XO is the object distance, and XI is the image distance. But make sure that when you are doing problems about mirror, there are 2 types of mirrors, concave mirror and convex mirror. The one that is bulged inside is the concave mirror, and the one which is bulged in the middle, that's called the convex mirror. Okay, so light falling on a concave mirror, that will always converge to a point on the focus. That is why it's called the converging mirror. But light falling on a convex mirror, that will go away, it will diverge. That's why it's called the diverging mirror. Now, for the converging mirror, when you solve problems, the focal length should be taken as positive. And for diverging mirror, which is a convex mirror, when you solve problems, the F should be taken as negative. Okay, if it's not given in the question, make sure if it's a convex mirror, you should put the F value as negative. Okay. Now, there's some more things that you need to know about magnification. Magnification, there are 2 formulas, height of the image by height of the object, or minus of xi by xo, distance of image by distance of object. This will be in the equation sheet, but most probably you will use this formula to find the unknown. If you want to find the height of the image, just plug in this for the 3 givens will be there and find the unknown. Okay, you can use this formula in the box here. Now, there are some more things that you need to know. If the sign of M is positive, if M is a positive number, the magnification that you find for the answer that you find for magnification is a positive number. For example, +1 or +0.6. These are all positive numbers, right? This sign of magnification shows the type of the image, if it is virtual or real. If it is positive M, it is a virtual image. And you know, virtual image will always be upright, isn't it? It's standing up. So virtual and upright will be the image if it's positive, but if M is negative, the answer if you get for M is negative, it's a real and inverted image. Okay, so the sign of the magnification will tell you if it is a virtual or real image. But the value of the magnification will tell you if the image is larger or same size or smaller than the object. For example, M greater than 1. Give me an M greater than 1 value, 1.5 is greater than 1, right? Or minus 1.6. These numbers are greater than 1 in their value. Don't look at the sign here. Just look at the value of the numbers, 1.5 and minus 1.6. The values are greater than 1. So this means the image formed will be larger than the object. It's an enlarged image. Okay. Now, if the value of M is equal to 1, then that means it's same as the size. The object and the image are same size. But if the value of M is less than 1, for example, 0.5 is less than 1, minus 0.7 is less than 1, right? So don't look at the sign. If the values are less than 1, then that means the image is smaller than the object, or it is a diminished image. So that is the meaning of the word magnification. So this is the equation ray diagram that you have for your exam. To draw the ray diagram, there will be a graph paper given with the object placed. You have to draw the picture correctly. So you know that it's a convex mirror. There is only one picture for convex mirror. So if you can practice this and draw exactly like this in the exam, you can score the full marks. There is only one figure for convex mirror. Okay, one picture, one ray diagram. So the object can be placed anywhere on the principal axis. It does not matter even if you keep away or near, no problem. The object will be kept for you in the exam. You just need to complete the rays. So the first ray, you have to start from the object, go straight, reach the mirror. You can draw a line to show where you reach. You can draw a straight line on the mirror and draw from there, no problem. You reach the point on the mirror here. You can extend and draw also, or you can keep it here. Then what happens when light falls on a convex mirror? It will diverge. It will go away, right? So it should go away. But from where does it go away? That is from the focus. So you have to keep the ruler on the focus here. So there's a F marked on your picture. Keep a ruler on the focus and the point where the ray touches the mirror. You keep it there. Place the ruler and draw in that line a straight ray. You can draw dotted lines to the focus. You can extend it to the focus by dotted lines, but don't draw lines behind the mirror because light do not come behind the mirror. Light only touches the mirror and diverges. Okay, so that's the first ray. Then the second ray, you have to keep the ruler on the object top and the focus. So keep a straight line from object to the focus and draw a straight line until the mirror only. Don't draw till the focus, just put dotted lines till the focus. What happens to the line that is coming towards the focus? It will be going straight back. So that's the reflected ray. So first ray is reflected in this direction. I will name it as 1. And the second ray is reflected straight. So that's 2. Now look at the 1 and 2. The reflected rays will not touch on the side of the mirror, but if you extend the lines behind the mirror, they will touch. So just put dotted lines from the 1 and the 2 towards the behind of the mirror. So from 1, you have already put the dotted lines. That's there. And from the second line, you haven't put yet. So you can just put the dotted line and see where both of the two lines touch. So you are extending the reflected lines of ray 1 and ray 2. Okay, and see where they touch. Where they touch, it's on the top of the principal axis. So draw an arrow. This purple color arrow shows the image. Okay, so this is how the image is formed in the convex mirror. When you look into the size of the image, you can see that it's very small compared to the object, right? And it is formed behind the mirror. So that's why it's called a virtual image. We will not get it on the screen. It is a virtual image. Now it is upright. It's standing straight up, right? That's upright. Then it is diminished or smaller than the object. So these three are the most important properties. You have to write them, but the fourth and the fifth are extra properties which will give you more marks. Okay, so I would ask you to write at least 4. So you can see that why it's virtual, because it's formed behind the mirror, right? You can write that as a definition. And the fourth property. Fifth one, it will be always formed near to the mirror, between the mirror and the focus on the other side. So behind the mirror, it's formed between the mirror and the focus. That's an extra point which you can add. So because of this property, you can see that the convex mirrors always form smaller images. So it can cover, when you place a convex mirror on any place, you can see that it can cover a large area. A large area can be shown in small size. That is why it is used as rear view mirrors in vehicles and security mirrors in shops. Okay, have you seen the parking mirror where they keep a mirror which is convex mirror to capture the whole area? You can see the whole area there. And also in the shops, you see the convex mirror to view the whole shop. And also in the side of the window side of our cars, we have the rear view mirror. So we can see the entire road behind us using this mirror. We can see the smaller image of cars, but the whole thing. That's why we use convex mirrors as rear view mirrors. Hope that is clear to you. Now about the problem solving part. It's very easy using the formula. You just need to know this formula is in your equation sheet. You just need to plug in the values and find directly, or you can find using the formula which you memorized too. So let's look at this, an object which is at a distance. So you know that it's object distance XO in front of a concave mirror of focal length 16 centimeter. So F is given. Since it is a concave mirror, you should know that the F is positive. So keep as it is. You want to find the image position Xi. So you can plug in the values like this and substitute in the calculator. Just plug in the calculator, put the Xi as X in the calculator. You can directly get the answer. But if you have learned the equation Xi is equal to F times XO divided by XO minus F, you can plug in the values and directly find the equation also. Okay, so if you plug in 60 times 36 divided by 36 minus 16. So when you solve it in the calculator, you will get the same answer, 28.7 centimeter. So you can use either the direct formula or the memorized formula to solve the problems. Hope that's clear to you. So these are all similar problems of concave mirror. Let's go to a final problem of convex mirror. So you have a 7.6 diameter ball that's located 22.0 centimeter from a convex mirror of radius of curvature 60 centimeter. So see, they have given the radius of curvature, which is 60 centimeter. So you can find the focal length. The relation between F and R is equal to 2 times F. So F is equal to the radius by 2, which will give you 60 by 2. That's equal to 30 centimeter is a focus. So first you have to find the focus. But since it is a convex mirror, make sure to put the F as negative. So you will be using F as negative 30 centimeter. That's very important. Now, the object distance is XO, which is 22 centimeter, and it's a ball's diameter from the mirror. So there's a convex mirror here, and the ball is kept on near it. So ball means it's the object, right? And the diameter means actually the distance from one end to the other end, which is actually the height of the object. So diameter here is 7.6 centimeter. Okay, so that, and it is at a distance 22 centimeter from the mirror. So you should know that what are the givens here. So now how do you find the image position? You can directly use the formula xi equal fxo divided by xo minus f. Just plug in the values. Minus 30 times xo is 22 divided by 22 minus 30. See? So when it's a convex lens, don't forget the minus with the focus. Otherwise, your answer will go wrong. And when you solve this, you will get the answer as minus 12.69. Practice that with your calculators. Okay. Now they have asked for the image diameter. What do you mean by image diameter? It is the height of the image. Okay. If it's a ball, it's the height of the image. So we will just use the memorized equation again. Hi by ho equal, a part of the equation is in the equation sheet, minus xi over xo. Okay, so you will just plug in the values. Hi is the unknown. You can put x in the calculator by 7.6 equal. There's a minus in the formula. And also there's one more thing that you need to focus. Yeah, you already got the answer as minus 12.6, right? Don't miss the minus. Again, put the minus 12.69 divided by the object position. Okay, so the 2 minus will cancel, and finally the answer would be a positive answer. So height of the image will be 4.39 centimeter. So this is how you solve the convex mirror problems. It's little different from the concave mirror problem. Make sure there is a minus in the xi and also minus in the focal length. Hope that's clear to you. Now the third FA, it's about, the FRQ is about the Snell's law of refraction, define the critical angle, calculate critical angle, total internal reflection, and the conditions. So these are the 4 parts. Let's look into the Snell's law of reflection. N1 multiplied by sine theta 1 is equal to N2 multiplied by sine theta 2. That's a formula, right? So this means when light enters from one medium to another medium, let's take the first medium here as air and the second medium as water. Okay, it's the refractive, every medium has a constant which shows how fast the light will travel in the medium. That constant is called the index of refraction, and it's denoted by the letter small n. And the values would be given for you in the exam. So for vacuum air, it is 1, and the values of other things are given here. So when light is entering from air to water, you can see that the air has index of refraction 1. Air is the first medium because that's where the light goes from. It goes to the second medium. So N2 for water is 1.33. It's in the table. So you can use those values here. Now, they say that when light falls from a small n to a big N, look at that. Where does the light bend? It will bend towards the normal. Do you know why that happened? So first you have to draw the normal here. Normal is the dotted line shown in the picture. So theta 1 is the angle between the incident ray and refracted ray, incident ray and the normal. And theta 2 is the angle between the refracted ray and the normal. You can see in this picture, theta 1 is bigger than theta 2. Why did this happen? Because when light enters from a high end region, from a small end region to a high end region like water, it bends towards the normal. And what is the reason for that? It is because in water, the speed of light is less compared to air. So when it slows down, the ray will bend towards the normal. Is that clear to you? So then Snell is a scientist who found that when you multiply N1 and the angle of incidence with sine, that is equal to N2 multiplied by the sine theta 2. So hope you know the value of what each letter means in the equation. Theta 1 is the angle of incidence, theta 2 is the angle of refraction. Okay, so we will solve problems with this. But also you should know how to draw this picture and understand it. When light goes from a lower end region to higher end region, like air to water, it bends towards the normals. Look at that. The theta 2 is less than theta 1. But when light enters from high end to low end, for example, from glass to air, it bends away from the normal. Look at the theta 2, it's very big now because light is moving away from the dotted line, that's a normal. So here, theta 2 is bigger than theta 1. And when light enters from, I have already told you that when it goes to a high end region, it slows down and bends towards the normal. These are very important points. When light go to a small end region, it speeds up and bends away from the normal. But if light enters perpendicular to any medium, it will not bend, it will just go straight. Okay, if there is no angle of incidence, it will just go straight. Now, there is only one quantity that does not change when light enters from one medium to another. Do you know which is that quantity? It's the frequency. Okay, but all other properties like wavelength, velocity, everything changes, direction, all of them changes, but frequency remains constant when the light goes from one medium to another. Now let's solve problems with this topic. The light enters from air to ethanol. So you have to know that the N1 for air is 1 and for ethanol in this would be given in the exam. It is 1.36 N2. And what is the angle of refraction? So they want you to find theta 2, right? So just plug in the formula, plug in the numbers directly. The angle of incidence theta 1 is given. You can put this directly into the calculator and solve for theta 2. If you are not able to, rearrange the equation like this, or you can memorize this equation and solve for it. Okay, the most important thing is set your calculators to degrees. It should not be in radian, it should be in degrees, and make sure that you get this answer by solving it yourself. Okay, if there any chance that you don't get it, that means you have to check your calculators degree and radian. Make sure it's set properly. Now the same topic applies to all of them. I'm going to the next topic in that question. It's a critical angle. So you can see that when light goes from a high end to a small end region, like water to air, this is air, so small n, it bends away from the normal, right? So theta 1 and theta 2 will be away from the normal. When you increase the angle of incidence, the angle of refraction also increases. So as you go on increasing, what happens to the refracted ray? Look at this refracted ray. When you increase to a particular angle, the refracted ray will not go to the air. It will go along the boundary between the air and the water. So we do not call it the refracted ray, we call it the critical ray. Because it did not refract, it just went through the boundary. right? And this angle of incidence we call by the name critical angle. So look at the angle of refraction at this time. It is the angle between the normal and the ray which is going along the boundary. That is 90 degree. You can see that it forms 90 degree with the normal, right? So that is the meaning of critical angle. Critical angle is the incident angle, actually. It is theta I. When does that happen? It happens when the refracted ray goes along the surface and the angle of refraction becomes 90 degree. So theta 2 is 90 degree and theta 1 is equal to theta C. Now, what happens if you again increase the angle of incidence? So you are again increasing theta 1 bigger than theta C. What happens? It will come back to water again. Look at that ray. This phenomenon is called total internal reflection. There is no refraction. All the light will be coming back to the same medium. When does this happen? This happens when the angle of incidence is greater than the critical angle. So that is one of your questions. What are the two conditions for total internal reflection to take place? One of the conditions is light should always go from high end region to small end region. Okay, because it will not happen when light go from air to water. It will only happen from when light goes from water to air. Okay, that's the first property. So big N to small n. That is the first condition. Light should go from big N to small n region. And the second condition is the angle of incidence, theta 1, should be greater than theta C. So that is the second condition. If you can memorize this, that would be a direct question in your exam. Please memorize these 2 points. Now, how do you find the critical angle of any medium? Let's find the critical angle of diamond. So there's a formula, theta C equal to N2 by N1. But make sure that theta C is this formula you have got from the Snell's law of refraction equal Snell's law of refraction itself, like N1 sine theta 1 equal N2 sine theta 2, right? So when the angle of incidence become critical angle, the sine theta 2 will become 90 degree and sine 90 is equal to 1. So this is how you rearrange the equation and get this equation. The N1 will go to the other side and it will come in the denominator. So sine theta is equal to N2 by N1, or you can take directly theta C. This formula will not be in the equation sheet, so memorize. If you want to find directly, memorize this formula. Theta C equal to sine inverse N2 over N1. So you know how to do sine inverse in the calculator, shift and sine, okay? You have to press shift sine, so you get sine inverse, and in bracket you have to put N2 over N1. But make sure that light is going from a big N to a small n. So that means the N2 value should be smaller than the N1 value. So you must be confused when there is diamond and air, which one you should take as N1 and N2, right? Light should go from diamond to air, but from big N to small n. So the N1 should always be the bigger value, okay? So always, there's a mistake that everyone usually makes. So make sure when you use the theta C formula, N1 should be, if it's diamond and air, the diamond's N should be the N1, okay? And the air should be N2. So this is how you have to solve the problems. So hope that's clear to you. That's all the same questions. Let's solve one exam type question. What occurs when a ray of light falls on at an angle of incidence 50 degree from water to air? So you can see that it's going from big N to small n. So if you want to know what happens when light is going from water to air, you have to first check the critical angle. So critical angle is the angle that you have already learned the formula theta c equal to sine inverse n2 over n1. Right? And remember what I told about you about the n1 and n2 values? The n2 should be smaller, or n1 should always be bigger than n2. Okay, so here you can see there is n air is 1 and n water is 1.33. So take the bigger one as n1. Okay, so that means the water is n1 and the air is n2. This is how you have to make sure that you're taking the correct values. Bigger is n1 always. Okay, so now you can plug it in sine inverse 1 by 1.33. Plug it in the calculator and you get the answer 48.75 degree. Look at that. That's the answer that you get for the critical angle theta c. But in the question, they have mentioned that the angle of incidence is 50 degree, which is bigger than the critical angle, right? So what happens to the ray? Will it get refracted? Or will it come back to the same medium? When light enters from a big N to a small n, and if the angle of incidence is greater than the critical angle, the light will come back to the same medium, right? So that means total internal reflection takes place. So that's the answer. The question is what happens, and you have to write total internal reflection, and there is no refraction. Hope that's clear to you. Now, the second part, find the angle of refraction in polythene. It's the same question using n1 sine theta 1 equal n2 sine theta 2. Hope that's clear to you because we have solved the problem already. You can directly, I'm not doing it again. Hope it's clear to you. All are directly given. It's from water to polythene. So water is the first medium and polythene is the second medium. So just take that as N1 and N2. Now for if you want the answer, the angle of refraction, finally you will get the answer as theta 2 equal to 48.2 degree. Okay, you can check that for yourself. Now the third question, what's the speed of light in chloroform? And the light and the n value of chloroform is given as 1.51. How do you find the speed of light with just the n value? Speed of light in chloroform, right? So chloroform is a medium in which light travels. Let it be v. We want to find the v, velocity of light in a medium. We have the formula for n. This is the formula for n. N is equal to speed of light by speed of light in medium. Speed of light in vacuum, that is c, divided by speed of light in medium, that is v. And you know that the formula, the value of c is 3 times 10 to the power 8 meter per second. That will be in your equation sheet. This is definitely going to be in your exam. A very important question and a very important formula. They have asked you to find v, so you can plug in the values directly and find it with x in the calculator, or you can rearrange to find the v. So if you rearrange, we get c by n. You can do it without rearranging also. So when you substitute 3 times 10 to the power 8 divided by the n is 1.51, the answer that you get is 1.98 into 10 to the power 8 meter per second. Okay, so this is how you have to solve this problem. It's very easy. So finally, the fourth question, draw the ray diagram of, this is also a drawing. So you have two ray diagrams, one for the convex mirror. There's only one picture, but for the convex lens, that's the topic here. In the fourth FRQ, it's convex lens drawing. You have four pictures according to the exam specification. One is greater than twice the focal length, equal to twice the focal length, between the focal length and twice the focal length and smaller than the focal length. So you have to practice drawing the 4 pictures. They can ask you any one of them, and then you have to write the properties and the location and also apply the thin lens equation to solve the problem. For the problem solving, they can bring either convex or concave lenses, but you use the same formula except for the equation. So you know that there are 2 types of lenses, convex and concave. And convex lens, when light falls on it, it converges. That's why it's called the converging lens. Remember that the converging mirror is concave. The opposite comes in the lens. Converging lens is convex. And when it falls on a concave mirror, it is diverging away. See that? So that's why a concave lens is called a diverging lens. Remember, a concave mirror is a converging mirror, but a concave lens is a diverging lens. So you make sure you learn these terms because they can, in the question, they will not directly say the lens name. They can give these names. Let's look into the ray diagram. I told you there is 4 ray diagrams. Let's look into 4 of them. Object at a distance greater than twice the focal length. What do you mean by this? Twice the focal length means 2f, right? And greater than twice the focal length means the object is kept beyond 2f. That means after 2f from the lens. So you will have this picture on a graph paper. You will have the lens and the object marked. The f and the 2f will also be marked for you. You just need to draw the 2 rays and show the image. So this is beyond 2f. Look at that. The object is kept beyond 2f. So there is f and 2f, which are at equal distances from the mirror. Then you can keep the object anywhere after 2f. So I kept it here. The first line straight. After touching the mirror, after touching the lens, sorry, it is lens. After touching the lens, it goes straight through the focus. See? Because a convex lens converges the light. So that's why it's going towards the principal axis and it's draw it continuously, continue drawing downward, extend it downward. So that's the first line. Ray 1, straight. Then at the center of the lens, it bends towards the focus, go through the focus. That's the first line. I'll mark it as number 1. And look at the second one. It goes through the focus on this side. Make sure it has to pass through the focus, reach the middle of the lens, then it goes straight. So that's the second refracted line. Where the both refracted lines meet, the 1 and the 2 refracted lines meet at a point, that is where the image is formed. You can see that they meet below the principal axis. That's why it is an inverted and smaller image. So always you have to know that when the object is beyond 2f, the image is between f and 2f on the other side, and it is smaller in size. Okay, so if you can memorize this thing, you can draw it correctly because there's a chance of making mistake if your line is not straight. So make sure you draw with ruler exactly as shown in the picture. Okay, now you get the image on the other side. So that means it's a real image.
Hello,
and real image is always inverted.
Okay, I will close
and
it
the
now.
size
Okay.
is small. As you see, it's diminished, or you can write smaller. And you also have to write where it is formed. It is formed between f and 2f on the opposite side of the lens. Okay, so that are the 4 properties. You have to learn and write these properties and also draw the picture. Hope it's clear to you. Next picture is also similar to the first one. Draw the ray diagram of a convex lens at a distance twice the focal length, which means the object is at 2f. This is the second picture. So you will have this graph paper with the lens and f and 2f marked and the object given, but you have to draw the image and the red lines. That's what you have to draw. Okay, so this is the object here at 2f. It's placed at 2f. You can see that the object, the green arrow is the object. Now, first line straight, going through the focus on the other side. See that? Straight and bend to the focus. Second line, going through the focus and then going straight. See? So that's the second line. So first line straight and then focus, second line focus and then straight. Now where does this two rays touch? This two rays touch exactly at 2F on the other side. Make sure your two rays touch on the 2F. If you didn't get on the 2F, that means you have made some mistake in the drawing. Redraw it again to touch the two lines at 2F again. And also, the two arrows should be of the same side. If you draw it correctly, you will get exactly like this. So that the properties is real and inverted again, the same size of the object, and it's formed on 2F itself on the opposite side of the lens. If you learn these properties, you can draw it correctly also. Hope that's clear to you. Now the third picture is also same. The object between F focal length and twice the focal length. So between F and 2F. So look at that picture. The object is kept between F and 2F. The same picture straight and passing through the focus. Then focus and passing straight. So the two lines touch here. It's an inverted image. And you can see that it's bigger than the object, right? So when the object is between F and 2F, the image is beyond 2F on the other side. It's just opposite to the first picture. Do you remember the first picture? First picture is opposite of that. When the object is beyond 2F, image is between F and 2F. The third picture is when image is between F and 2F, the object is beyond 2F, but it is bigger. That's the difference. So real, inverted, bigger, or you can write enlarged and formed beyond 2F on the other side of the lens. So that are the properties. So first and the third picture are opposite to each other. So you can learn the properties in that way. Now the last picture for the convex lens is different. This is a case in which a convex lens forms virtual image. So convex lens is a lens which can form both real and virtual image. It can form virtual image only at one case. That is when the object is between the focus and the lens. Look at that. The focus and the lens, but the object is kept in this place. See the arrow here, the small object is here. So how do you draw the ray diagram? Just like that. First, a straight arrow reaches the lens, is the first line, okay, going straight, and then it passed through the focus. So this is the first line coming through the focus. Then second, it has to come through the focus and go straight, right? But focus is already behind the object. So how do you do? You keep a ruler on the focus and on the object and extend the line of the lens upward so that you know where the middle line of the lens. So it should look like the light is coming from the focus, but the light should only start from the object. Don't draw line from the focus. Only draw dotted line from the focus. You should start the line only from the object. Okay, but it should be coming straight from the focus. Then reach the center of the lens and go straight. So this is the second line. You can see that the first line and the second refracted line does not meet and will never meet on the other side because they are going away from each other, right? But if you can extend it on the same side of the object, they can touch. So what you need to do is take the ruler and draw dotted lines straight from the first ray and the second ray towards the object side. So first ray, keep the ruler on the second ray and draw straight, and keep the ruler on the first ray and draw straight. So that will meet at a point here. Look at that, the dotted lines meet at a point and you get a very big image of the object. So there's a virtual image because it's formed on the same side and it is upright, it's very big, and it's formed on the same side of the object. Okay, so these are the four properties that you should write, and you should study this because it's different from the other pictures. Now for the problem solving part, you have to use the same formulas. Everything is same like the mirror. Only the thing is, convex lens is a converging lens, and F should be positive for convex lens. Whereas in convex mirror, you use F as negative, right? But in lens, it's a converging lens, so it's positive. And concave lens is a diverging lens, so F is negative. So that's the only difference between the lens and the mirror formulas. Everything about magnification is same as the definitions are same as for the mirror. Now, can you identify this lens in the picture? You can see a very big image of the flower and the butterfly, right? So which lens forms very big image? You have just seen in the fourth ray diagram. It's the convex lens, isn't it? And when does this convex lens form a bigger image, just like you see in the picture here? When the object is kept between the focus and the lens, you get a bigger image. See, the candle became very big. The image is very big here. So when the object is between F and lens, so not mirror, it's about F and lens, the image became very big. So that is the two conditions for convex lens to form a bigger image. So this question, when do a concave lens produce a larger image on the other side inverted when the object is between F and 2F, right? It produces a larger image beyond 2F. That picture was also there for drawing. So these are the questions related to the picture itself. Hope that's all clear to you. You just solved the problems. Same as other one, but the sign of the focal length should be understood. Okay. Now, for the concave lens, you don't have any ray diagram, but the properties of the image should be learned. The object is kept any distance. You can see that you don't have to draw the figure. You just need to know the properties. When the object is kept here, you can see that the image does not form on the other side because the rays go diverging from the concave lens. When you extend the two rays, the image formed is a very small image by the concave lens. So concave lens only forms diminished image, okay, or smaller image, and it is formed on the same side of the lens. So it is virtual, and virtual image is always upright, and it is located between the lens and the F. It's near to the lens itself. So these are the properties you should be learning about the concave mirror. So let's go to last final question about the convex lens. Okay. So this is going to be the type of question that you would get, a question with 4 parts. An object is placed at a distance of 20 centimeter from a convex lens. So this object distance XO, and it has a focal length F given, and you want to find the image XI, right? You can directly use it in the lens formula. It's a convex lens, so you should know that F is positive itself. So you will, I'm just going to substitute the XI formula, FXO divided by XO minus F. All the values are given in the question itself. So you can substitute it directly. 20 into 4 by 20 minus 4. The answer would be 5 centimeter. Okay. Now, second one, if the object is 2 centimeter high, how tall is the image? You can use the equation HI over HO divided by minus XI over XO. Okay. So you want the height of the image. When you plug in the calculator, you would get the answer of HI as minus 0.25. Okay. So that's a image. Now, what about the orientation of the image? It's a negative answer, and it's a you can see that its answer is also less than 1, right? So that means you can also find it from the HI. Look at the HI value and the HO value. The height of the object is bigger, right? 2 centimeter, and the height of the image is smaller and negative. So what do you mean by a negative answer? Negative answer means it's a real. Inverted. Real is always inverted. And you can see the size difference. Object is 2 and the image height is 0.25. So it has become smaller than the object. Okay. So this is the orientation. Orientation actually means if it is inverted or upright. That's the meaning of orientation, but you can write all the properties. Okay. Now, calculate the magnification. Magnification M is equal to, you can use any of the properties, minus xi over xo or hi over ho. You can use any of the properties. I will just use minus xi over xo. So minus xi is 5. Over xo is actually it's a m it's a m value. Please find the hi value. Okay, substitute in the equation and find that value. The m is minus 5 over. The distance of the object is 20. Minus 5 over 20. That's minus 1/4. That's equal to minus 0.25. Okay, the magnification don't have any units. So from the value of magnification, we can also confirm that it's an inverted, real, and smaller object. So these are all the questions for FRQ. Hope that's all clear to you. Now the time for the class is over, so I have to wind up. If anyone has more questions about MCQ, you can contact me. I am ready to help you. Okay. So that's all. All the best for tomorrow's exam. Prepare well, learn the formulas, and practice drawing the ray diagrams. So good luck to all of you. Bye. Thank you. Use light energy. So if you have a bar.
6, 7.